Today we'll talk about experiment for flow measurement, and we are from group 2. I'm Zhen Hui, and we have Anis, Intan, Haris, and Melvin. This is the contents that we're going to present, and my part will be report summary. For the abstract, this experiment is done with the flow of measurement test bench. Through the application of Bernoulli's principle, the relationship between flow and pressure is determined. It was found that when the flow rate increases, the velocity will increase and the pressure will decrease. In this experiment, we had to carry out several precaution steps in order to get more accurate data and not to broken the machine. Then the rotometer reading is set slowly to the value where the manometer reading chose had the maximum and minimum reading, which is the height difference will be the largest. When we gradually adjust the rotometer to 200 liters per hour, the procedure is repeat for office plate, nozzle, and venturimeter. From the data analyzed, we can compare that in different equipment, the flow rate will be different, and we had found venturimeter is the most accurate measurement because the discharge coefficient is applicable and less but closer to 1. Our objective for the experiment is to compare the discharge coefficient of different types of flow measurement methods. For the introduction, flow measurements are easily found in our daily life. Furthermore, a flow meter is used to calculate the flow rate of the fluid or energy to allow the process to be monitored and to ensure that the final product meets the required quality. The principle of the flow meters is based on the change in static pressure or pressure drop or head. Hence, it can be related to the change in velocity is affected by the change in cross-sectional area of the flow of fluid.
Okay, now I will explain the theory. In this experiment, there will be three types of flow meter will be used, which is orifice, nozzle, and venturi. All of these three flow meter, they will operate in the same concept, where the change in velocity in fluid depend on the change of the cross-sectional area that will affect the differential pressure between two measure points. So we're going to orifice first. So orifice is where a restriction with an opening smaller than a pipe diameter which is inserted in the pipe. Due to the smaller opening area, the fluid velocity will increase and hence causing the decrease in pressure. The flow rate can be calculated from the measured pressure drop across the orifice plate P1 to P2, which means this P1 and this is P2. So in this case, we're going to use the Bernoulli equation. So Bernoulli equation can be applied with the assumption of the flow is horizontal between point 1 and point 2. So the equation of the Bernoulli equation can be expressed into three equations. So and the below is the explanation of each symbol. Okay, so the next flow meter is nozzle. So nozzle is applied at the same principle and calculation as the orifice, with the only change on A2. A2 is basically this part. So the difference between nozzle and orifice is only the shape of the restricted opening, where the nozzle is approximately a quarter eclipse. Okay, so the last flow meter is venturi. So the venturi is consists of rapidly converging section which increase the velocity of flow and hence reduce the pressure. It then returns to the original dimension of the pipe by gently diverging the diffuser. Okay, by measuring the pressure difference, the discharge coefficient can be calculated. This is particularly accurate method of flow measure as energy loss is very small. Same principle and calculation as the orifice plate in applied to the venturi, with only change is on the A2, means the area of this part.
The application for the experiment is widely used in our daily life, especially in industry. The first one is a water supply from the main tank to a house compound. We use a different diameter of pipe to ensure the different pressure of water flow to the housing compound. Even in our house, we have a main tank and the pipe will supply to each of room in our home, in our house. The next one is a oil flow from the underground to a consumer, such as at the petrol pump. The oil flow from the underground to a pump that we use. for the gas, mostly used at the hospital, such as to supply oxygen to a patient. We use a small diameter of pipe and also have other size of pipe. Okay, now we go for the apparatus for the experiment. The most important thing is we need to have a main switch box. Now, number 2, flow control valve, water inlet and also water outlet. Next one is multi-tube manometer, which is we use to measure the different pressure between water outlet and water inlet. Orifice plate and nozzle, which is used to run this experiment. The next one is ventilation valve, the ventrimeter and rotameter. Rotameter we use to obtain the actual flow rate of water. The gate valve, and last one is some temp. Okay, now let's go for a methodology. Firstly, this experiment is to compare a discharge coefficient. Okay, number 1 is the main switch and pump is turned on, and then the flow control valve is open. The gate valve is open until its maximum. Then the gate valve is slowly closed till reading of rotameter reach 200 LH. The gate valve is slowly open until level of water in manometer change, and then observe the level of water in each tube. The next one is gate valve is slowly closed when the reading H1 and H1 reach maximum and H2 minimum. And then the step is repeated for the next experiment with the 100 decrement until the rotameter reach minimum, which is 200 LH. The change at the manometer tube is recorded for our data. Then the gate valve is closed. The device is changed with a nozzle for the next experiment. Then identify the H1 and H2 for the next device and repeat the step for the next experiment.
Okay, so now I'm going to present the raw data and the analysis that we could get from the experiment. The table on the slide shows all the data that we got collected from the experiment by using orifice plate, nozzle, and ventrimeter. Based on the raw data that we got from the experiment that shown in previous slide, we can find the actual flow rate, theoretical flow rate, and the discharge coefficient from the equation respectively. To get the theoretical flow rate, we using the equation 1, with theoretical flow rate equals to the cross-sectional area of a flow rate times with the square root of 2 times with P1 minus P2 over rho times with 1 minus cross-sectional area of the flow rate divided by the internal cross-sectional area of a pipe power of 2. Since P1 minus P2 equals to rho times gravity constant times with the differential height in manometer between 2 points, thus we got the final equations of the theoretical flow rates by substituting the P1 minus P2. Thus, the final equations of the theoretical flow rate equals to the cross-sectional area of the flow rate times with the square root of the 2 times with gravity constant times with the differential height in manometer between 2 points divided by the 1 minus cross-sectional area of the flow rate divided by the internal cross-sectional area of pipe power of 2. The discharge coefficient can be calculated by dividing the actual flow rate that we measured from the experiment with the theoretical flow rate that we could get from the equation above. Okay, so now we move on to results and discussion. As you can see in the slide shown there is data for orifice plate where table 1 shows the data for orifice plate where Q actual, Q theoretical, and delta H is calculated. Delta H is calculated from H1 minus H2. To get the axis, to plotting the graph, we need Q actual, delta H, log Q actual, and log delta H to plotting the graph. And the graph need two axes, and the axes are log Q actual versus log delta H. And we get nearly the straight line there. Same goes to nozzle. We get almost straight line too. And lastly, the ventrimeter is almost the same. So the discussion, the questions in the first discussion will be the differences on water level H1 minus H2 in manometer with different types of flow meter relate to answer with pressure losses associated with the type of flow meter. Firstly, for orifice plates, the height of the H1 increases as the volumetric flow rate increases, while the height of the H2 decreases because of the nozzle with an opening has a limit. The cross-sectional region changes diversely. The region for the opening is smaller. At H1, the height of the water level is higher because of the pressure in the fluid was produced to flow through the smaller opening area. Thus, the fluid velocity increases as the pressure decreases at H2, and it reduces the height of the water surface. And next, we move on to nozzle. Nozzle, the height of the H1 increases as the volumetric flow rate increases, while the height of the H2 decreases. This is because a nozzle with an opening has a limit. The cross-sectional area of the nozzle is roughly a fifth of the ellipse. The opening of the restriction causes a frictional force to occur in the tube. As the fluid increases the nozzle acceleration, the velocity increases, thus reducing the strain, allowing a relatively large difference in height. Thus, the decrease in pressure caused the H2 reading to drop. Lastly, venturimeters. At H1, the value of the water level is greater than H2 in venturimeter. This happens because of the venturimeter consists of a segment that converges rapidly. While the velocity is lower, it makes the pressure at H1 greater, but the pressure continues to decrease as the fluid moves through the H2, while the velocity of it increases to lower at water level at H2.
For discussion number 2, we need to identify the difference in discharge coefficient value, which is CD, for each of the flow meter and the ranking of the flow meter according to their accuracy. So as we can see here, there are a formula to calculate the CD and already determined in the previous slide. Then to identify the accuracy for each flow meter, we calculate the average of coefficient CD and get the answer as it states there, which is orifice plate is 0.357, the nozzle is 0.759, and the venturimeter is 0.9. From this average of CD, the venturimeter is the most accurate, followed by nozzle and orifice meter. The CD of the flow meter should be less than 1 or nearest to 1, and the venturimeter got the CD of 0.9 that approximately to 1, and the differences between 0.9 and 1 is only 0.1, which is the smallest one, compared to the nozzle and the orifice that getting more differences with 1, which is 0.241 and 0.643. Next, for the discussion number 3, the question asks for the factors that contributing to the errors or inaccuracy in experimental data and the possible recommendation to improve the existing result. Alright, for the first one, factors that impact the experimental data is parallax error, which is the eye of the observer are not aligned to the reading scales of rotameter and multi-tube manometer. To improve these errors, the eye should be perpendicular to the reading scales. The second thing, there are some air bubbles trapped inside the tube and make the typical reading less accurate. So to avoid this inaccuracy, we need to make sure that there are no air bubbles inside the tube by allow the air bubble trap going out of the system. Next, the experiment for each flow meter was held once. We should to do it repeatedly at least twice for each flow meter so that the data we get are more precise. In addition, students need to be able to study and understand the flow of experiment and the lab manual before conducting the experiment.
So the conclusion for this experiment is, the objective of this experiment is to determine and compare the coefficient of the discharge for the series of flow measurement devices such as orifice, nozzle, and venturi. The CD value that being obtained is 0.357 for the orifice, 0.759 for the nozzle, and 0.9 for the venturi. Okay, through the data that being obtained through the experiment, we can conclude that the venturimeter has the most precise and accurate among the two other flow meter device. where Venturi meter gives the highest value of CD because in Venturi meter losses are less, so coefficient of discharge is higher where in the orifice and nozzle due to no converge and divergent cone, there are more losses and hence its coefficient of discharge is less. Okay. When the next velocity when the velocity of the flow rate increase, the pressure in the fluid will decrease. By that, we can say that the all of this measurement device is based and obey the Bernoulli principle. So in this experiment, there are few ways to improve the experiment and obtain the best result. Firstly, before we run the experiment, we must study the manual lab that have been given to us, so we can run the experiment smoothly and fully understand the unit and procedure. Next, when we taking the reading from the manometer, it should be taken at the eye level which is perpendicular to our eye to avoid the parallax error. We must avoid parallax error to get the accurate data and result. Last but not least, the experiment should be repeated 3 times in order to get the average reading. This will reduce the deviation from the theoretical result. To get the better result, the experiment should be repeated at least twice. So that's it from our group. Thank you for watching.